Hello everyone, hope you're doing well. In today's video, we will solve the Leetcode 3-sum coding interview problem. In this problem, we have been given an array of numbers, as you can see on the screen, and we want to find all triplets or three numbers which add up to 0. So let's call this input array nums. And let's say the three numbers in the triplets are located at indices I, j, and k. When we add the three numbers at these indices, we must get the value 0. And the condition on the indices is that they are different from each other. The condition on the result is that there should be no duplicate triplets in it. I'll present an optimal solution with a time complexity of big O of n squared. To help understand the approach that I'm going to take, I first need to represent these numbers on a number line. For this, we need to sort the input array. After sorting this input array, we get this array. Now let's focus on this sorted array. Here we can see that I have the values in the increasing order, and I've also marked the indices for every element. Now let's use our first number in the array as the first number in the triplet. Having fixed the first element in the triplet, we need to find the remaining two elements of the triplet. Let's indicate the first element in the triplet using the index I, and now we need to find the remaining two elements in the remaining part of the array, which starts at index 1 and ends at index 5. We'll use the index j to indicate the start of this remaining array, and the index k to indicate the last element of this array. So the logic to solve this problem is to check the sum of the values at indices I, j, and k. Okay, if it is equal to 0, then we have found a triplet, and if it's less than 1, that means we need to move towards the right of this array because we want to get closer to 0. If the sum is greater than 0, then we need to move k to the left so that the sum is closer to 0. So looking at the sum of the values at index I, j, and k, we get -3. Since -3 is less than 0, we will move the index j by one position to the right. At this point, we can see that the sum of the three values is still -3. So we will again move j one position to the right. Now we can see that the sum of the values at indices I, j, and k is -2, but it is still less than 0. So we will again move j one position to the right, and we will keep doing this till j is less than k. Now we can add up the numbers again and we get the sum of -1, but at this point we can no longer move j forward. So that means that for the first value of -4, there are no possible triplets in this input array. The next step is to increment the index I. We will also reset the values of j and k such that j points to the number after index I and k points to the last element in the array. As before, we will calculate the sum of the values at indices I, j, and k, and we see that -1 plus -1 plus 2 is equal to 0. So that means we have found our first triplet, and it contains the elements -1, -1, and 2. Once we find a triplet, we want to move the index j one position to the right, and we recalculate the sum and we get +1. Because the sum is greater than 0, we want to move to the left of the number line or the left of the array, so we will decrement k by one position. After that, we will recalculate the sum, and we can see that the sum of the values at indices I, j, and k is again 0. That means we have found another triplet. So we will add these three values in the results. Now we cannot move j any further because that would mean that j equals k. The next thing we need to do is check the next triplet, and we will have to move the index I one position to the right. But we can see that the current value at index I is -1, and the new value at index I will also be -1. And this means that if we were to recalculate the triplets, we would get duplicates. Hence, we will skip the index 2 and move I to position 3. Now we can see that I is pointing to the value 0 and j and k are pointing to the values 1 and 2 respectively. But if we add the values up, we get the total of 3, which means that we need to move k one position to the left. But that would mean that k equals j, and that means that we can no longer find any more triplets. At this point, we have scanned the entire array for triplets and calculated the results. So here's the code for the approach that we just discussed. This is not the complete code. We still have to handle some edge cases, which I will discuss shortly. First up, we define the results, which is a list of numbers, which we will return from this method. We sort the input array so that we can easily detect duplicates. We start iterating this array using the index I. Every time we iterate through this loop, we need to make sure that we don't recalculate the triplets for the same value at index I. Hence, we need to check if the current value at index I is the same as the previous value at index I, then we skip the current value at index I. On line 11, we initialize the index j to be I plus 1, so that's one position after I, and we initialize the index k to point to the last element in the array. In the inner loop, we want to then check the pair of numbers which, when added to the number at index I, give us 0. And we do this calculation till j is less than k. So first we calculate the total, which is the sum of the values at index I, j and k. If the total is 0, that means we have found a triplet, and we simply add a list of these numbers into our results. After doing that, we move our index j one position to the right. If the total was less than 0, that means we are on the negative side of 0, and we want to increment j one position to the right. On the other hand, if total was greater than 0, then we need to move k, that's the index k, one position to the left. This is because we want to find the values which add up to 0. Now let's run the program with the given input and see if it passes. Okay, so this is fine. Now let's think about an edge case. I'll go into the test case, and here is my input array, and I'll add another number, and let's run it now. Now here we can see that the output returned contains duplicate triplets here, and since duplicates are not allowed, this test case fails. Let's have a look at this code here. After sorting, our array would be equal to this. So the first time when we found our triplet -1, 0 and 1, that is -1, 0 and 1, we added it into the results. And once we find a triplet, we are incrementing j by 1. So j would be pointing to this second 0. Note that the previous value at index j was also 0. That means we are now processing a duplicate triplet. So we need to add a new condition here, wherein we not just increment j once, but we increment it till we see a new unique element. So for example, when j points to this first 0 and we have found a triplet, we need to move j to this 1 and not move it to this 0. That way we'll be able to skip over a duplicate. So we increment j till we get a new number. But we also need to make sure that j continues to be less than k. Now let's run this test case again. And here we can see that we have correctly returned the triplets from our function. So that was it, guys. Thank you very much for watching. If you found this video useful, please do consider subscribing to my channel as it helps me a lot, and please do remember to like and share this video. Thank you.